this is Jingbo Shan. I'm assistant professor at computer science and data science, and it's my pleasure to explain ChatGPT for you, and I promise you I won't give you any formula today. So a little bit more about ChatGPT. So if you are familiar with all this kind of term GPT, and you know, like as the ChatGPT itself says, it's built upon GPT 3.5. So it's a reasonable guess there's some GPT-3, GPT-2, GPT-1 model, right? So this is kind of the trajectory of all this model development. Everything started from this transformer. And then we have GPT, GPT-2, GPT-3, scaling up all the way. And we have the instruction tuning to get the GPT 3.5 at the 5th step, and then we get a ChatGPT. So today we're going to follow this trajectory and try to explain every single new technique concept here. So we will start with the transformer. I won't give you any details about how it works, any formula. I promise that there's no. So you only need to know that transformer is a neural network model with universal approximation capability. It can approximate arbitrary function in the world, and it's designed to max out the running time efficiency from GPU or from TPU. And it's basically two buzzwords, multi-head attention mechanism and encoder-decoder. So if you know all these terms now, you're good to go for this transformer. So let's more focus on this, how can we train transformer to become GPT models. So one thing we need to understand is the language modeling. So language model basically describe the generation of the text, how we generate, how we write and read or speak all these English sentences. So this is a basic idea of the language modeling. And if you think about a typical English test question, it can be some question like this. I have a sentence here, say, today we are here chatting about GPT at UC San, and then I give you an underscore, ask you to fill out the last word here. And with a reasonable guess, you will say it's UC San Diego, since we're here in Supercomputer Center in San Diego, right? So the task here is basically to predict what is the next word given all the previous words. And if you give it a name for this task, it's called autoregressive language model. And there are many representative models following this line, using this as the objective to train the neural network. And the two we'll talk about today is Elmo and the GPT. So let me give you a more concrete idea about how we can train a neural network model using this language model objective. So this is a work I've done 2 years ago together with Rajesh Gupta's group. And we're working on these smart building cases. And I was told there are about 5,000-ish sensors in every modern building nowadays. So every sensor has a name. And the name is curated by the building vendors who install these sensors. And name itself contains a building name, room ID, functionality, many other information there. But it's really hard to understand, like, how can we segment this sequence of characters into different meaningful units. So we actually trained a fairly small language model, try to leverage the character sequence given all the previous characters. How can we guess what's the next character? So it's a character level language model. And we use a very simple recurrent neural network, only one layer, and we made it work for this segmentation, achieving more than 90% accuracy by segmenting these character sequences into meaningful word pieces without any human supervision. So the supervision here is given by the sequence itself. We're just looking at the ordering information here. So when we scale it to the human language, we definitely need more complicated models. So there are different ways to scale it up for the recurrent neural network. You can stack it. You can follow this stacked way or this translational manner. And stacking is more popular. And then you can realize that the very first pre-trained neural network language model is called this Elmo. It was firstly developed by Artificial Intelligence, Allen Institute of Artificial Intelligence. And it's a bidirectional, stacked, long short-term memory neural network model. And it got the best paper in the North American ACL conference in 2018. So it's reading the document from the left to right and the right to left at the same time, try to get the idea of the entire document from the both sides and get the final representation for every token. So that's a key idea. And almost at the same time, there's another group of people, they think about the English test question in another angle, say, oh, maybe we actually have another more complicated form to fill in the blanks. So this is called a masked language model. You can have multiple words being masked in the same sentence, and then you can guess what is this, right? So here we mask a we and a GPT, and maybe you can guess, can be we, can be they, can be GPT, can be other models, other techniques. So following this training objective, we have BERT, Robota, Electra, and many other models following this masked language model objective. So BERT, without any surprise, won another Best Paper award in the same NACO conference next year. And it's basically doing two things, the masked language model plus the next sentence prediction. But later, more recently, research has shown that the next sentence prediction, NSP, doesn't play any significant role here. So it's still the language model itself contributes the maximum in these modern models. So these are the very first language models we have seen in the literature of NLP. And the key advantage of the neural language model is it does not require any human annotation. You just present the raw text data to it, you can do the training. You can give it the news articles, you can give it social media posts, you can give it scientific papers or medical reports, and it can just try to master all these things by reading these documents. The good news is we don't need to do annotation, so we can actually feed all the possible text data in the world to the model. So it's nearly unlimited, given that we are writing, we're speaking, we're creating all this text data every day. So now it's a very reasonable next step to think about, since we have nearly unlimited training data, we can keep feeding more and more data there, and at the same time, we can make the model more complicated. So this becomes the next step for GPT. So you can see here, Elmo and the BERT, they are the very first one in this plot. And later on, we have GPT-2, T5, GPT-3, and so on. And ChatGPT is based on GPT-3, so the model size is roughly the same. So you can see here, it can be another more slow, right? When we're scaling up the model, when we have more complicated model, the capability will be expected to be stronger. So let's make an analogy to the human brain size. If you think about the intelligence in these animals, why we human can master language, while I think it's a unique feature for human, right? So we actually have a much larger brain size compared with other animals. So there's a quote from a paper saying the evolution of the human brain is a kind of when bigger is better, right? So the same applies to the language model. The researchers try to examine the capability of this language model on different tasks. And you can see here, there are a few curves, they look like this. It's almost a flat in the beginning, and that level is similar as a random guess to these questions. And suddenly, when the model complexity, the x-axis is the model size. When the size passes through a threshold, you can see that there's dramatic growth of the capability of the model. And actually, some of them you can even reach nearly 100% accuracy for some simple tasks. So this is called the emergent ability. You can see this emergent ability only when the large language model is large enough. So what is this emergent ability? So prompt is another way, I think it's a fundamentally new method that you can play with these models. Because in the past, every machine learning model is customized for its own application. It only takes the input following a predefined format, and then it gives you the output following the predefined format too. If you imagine you're playing with a classification model, it only works for sentiment analysis. You present a movie review to it, it tells you positive, negative, maybe neutral, but nothing beyond that. But prompting is a nice way. The user gives you a natural language prefix, and that prefix can define a task. For example, JDK is developed by underscore. Well, the answer might be controversial, but BERT can successfully tell you some reasonable guess, like Oracle, right? And language model will give you completion for this sentence. And the completion can be one token, can be more token. Here, every token is kind of a word, but it's usually smaller than a word. And you can also constrain the generated token within a predefined set. If you're doing the sentiment analysis, I can present to the model a movie review and ask the model, what's the sentiment here, and underscore. And when you are collecting back the generation, you tell the model, I'm only looking for positive or negative. So in that case, The model will understand you're doing the binary classification, you're working on sentiment analysis without any specific training on sentiment analysis data. It can give you some reasonably good performance. So the same language model can handle different tasks. So this is a very strong capability that we have never seen before in those domain-specific or application-specific models. And this is not the end of the prompting yet. I put a few shot there. So how can we use the few shot example to improve the prompting performance using large language models? You can actually give a few examples in addition to the task description. For example, if you want to translate English word to French word, so this is a task, right? Translate English to French. And I can give you some examples. Like, see, here are some words I know that this is English, this is a translation to French, and I put a kind of placeholder there to tell the format of the task. And then I give 3 examples here, and for the 4th one, I put it as a prompt. I leave it a blank at the end to ask the model to finish that. So this is similar to the Python interpreter. Justin just showed you, like, if I tell you it's 3 plus 5, you should give me 8. So that's an example we give to the model. The model never learned this before, but we try to teach it on the fly. And usually 3 to 5 examples should be good enough to tell the model what you're really looking for. And I actually tried this when I was designing a quiz for an online course I'm teaching this quarter. It's an NLP course. And I want to have some conceptual questions, but I don't want to write it myself. I asked ChatGPT, so here I'm teaching this course, this is a context, I need some multiple choice questions. And I know there's some questions I like, I put it there as example. And then try to, can you tell me more similar questions like this? It has done a great job, while the answers are mostly wrong, but the question itself is great. So I can start from there and fix the issue and then import this to the online course, which is great because if the student asks ChatGPT, they will get the wrong answer. So you can see there's some prompting capability now for the language model, and it's still the sentence completion. But you can see in the ChatGPT, we always give it a command, like write something, do something, right? It's not kind of completing a sentence here. So what's happening in the middle is there's some instruction tuning and with reinforcement learning and a human feedback in the loop. So this figure, if you have ever read any news about ChatGPT, you probably have seen this figure before. But the general idea here is people train a grader to rank the generated completion and tell them like which one is better. And this is a human feedback. Human do the annotation. You ask the language model to generate something, and you can also observe in the interface of ChatGPT, you can ask this to regenerate the answer. And the new answer will be very likely different. So you can ask the model to generate a few answers and ask the human to rank them. And we try to use this data to train a grader. And this grader will be used automatically to improve the language model's generation following the reinforcement learning framework. So this is a general idea, and then it will better follow the human instruction, better align with the human expectation about what to do given that instruction. So in general, we think about a very broad case is, what is ChatGPT? ChatGPT is just a GPT 3.5 that can chat, right? So we have GPT 3.5 there. We have this instructed GPT, and there are additional things being done in ChatGPT. First thing is we fine-tune this based on the chat data, and it will make conversation. You will find that it tends to give you a longer response and try to engage you in this conversation. And they also added those additional safety guard, like you probably can see it many times. As a large language model, I cannot do something, right? And this is something they added additionally. It's more like some classification model to tell ChatGPT, like, you should not answer these questions. And they also build this in a multi-turn dialogue system, and it's conditioned on the previous message. So you can see here on the right-hand side, this is the API you can call for ChatGPT. And in the very beginning, you have the system setting. You tell that you are a helpful assistant, but they also realized later, like the system actually didn't pay, almost pay no attention to this sentence. They promised they will improve in the future. And then it's a chat history, like what you have chat with it before. You provide this as additional constraint or condition that the model should be aware of. And then the model make a prediction to give you the next one, like what's the next sentence the assistant will tell you. So this is the general idea, like you can interact with a ChatGPT. And if you pay $20 a month, you will be able to have access to something called ChatGPT Plus. And the back end of the ChatGPT Plus is something, a multimodal language model called GPT-4. So there's almost no public information about GPT-4. That's why people criticize OpenAI become the closed AI now. But the fact is, GPT-4 is trained at least based on image and text. So it's a multimodal, text and image. There are two modalities here at least. And it has more parameters than GPT-3. These two are for sure. And there's a rumor, and I copied this picture from the rumor source saying GPT-4 has 1 trillion number of parameters. So this is a huge number. If you think about how many neurons we have in the human brain and how many connections between these neurons, in neural network, usually one connection means one number of parameter. And in GPT-3, we have this 175 billions of the parameter, and the rumor says there's a 100 trillion parameters. It's significantly larger. So here comes to my personal guess. Of course, it will be more than 1 trillion because you can see from the previous scaling law picture here, we are kind of getting the next magnitude over years. So given that we are already there in hundreds of billions, 1 trillion is not a big issue, and it's a reasonable thing to expect. And I'm afraid it's not more than 100 trillion because given the current computational resources we have, given the current amount of data we have, I feel 100 trillion might be too large to train, unless OpenAI has something like magic, I don't know. So if you think about how can we deploy our own GPT model, how can we train our own GPT model, based on my lab's experience, we can at least afford something like fine-tuning a GPT-3 scale model with a cutting-edge NVIDIA A100 cards, and you definitely need more than 8 cards than this to do this. And that single machine can cost already hundreds of thousands of dollars by machine itself, and you need to consider the electricity and all the other things. But if you roll back to BERT, if you roll back to Elmo or GPT-2, you can afford it using a slightly weaker machine, but it's still a high-end GPU server. And if you think about all this, then it's definitely creating some barrier for the entry level for this AI game. But the good news is the OpenAI API is actually cheap enough. My student has been playing with those APIs for a while, and I told them to try to spend the money. I will support your research. And after a month, they give me the bill. It's only $40. So it's really not that expensive, and I strongly encourage you to give it a try, and you can understand what's going on there. So we will have more open-ended discussion, but I will just try to give a short discussion myself here. So there are many people saying that ChatGPT can be the spark of the AGI, the artificial general intelligence, and which I can see some hope to. And how can we deal with multimodal data? GPT-4 already did that. Then if there's a GPT-5, we also need to think about what kind of a data source we can use to train an even larger model. From the machine learning perspective, we always expect a larger model needs more training data. We already use the image data, then what's next? My guess will be video or maybe some other audio or data that widely available online. And also the impact to the education, whether or not we should include ChatGPT in our curriculum, like whether we allow the student to use this for their homework. I think there are already a lot of discussion going on campus, and I'm happy to see the Academic Integrity Office will be evolved in the later panel too. And with there are definitely impact to the domain size, to our daily life, and also the job market. There are many people, like master students, asking me, like, how do you think about this job market things? So I have a feeling that if your work is closer to the machine, if your work is closer to the computer, it will be more likely your job will be affected. I'm not saying replaced, but affected by this ChatGPT stuff, because it's easier for them to get the training data from your job routines, and it can automate some of the modules in the middle and make your job easier. So my understanding for the AI is more like augmented intelligence. I would expect AI will augment the capability of the human. And if you think about what are the strengths of the AI, it's actually complementary to human. ChatGPT 3 used about 45 terabytes raw text data to do the training. How can we imagine we can read such a large number of documents? I mean, including all the people in the room, I think throughout all our life, we probably cannot read through all the documents there. But the good news is AI nowadays can help you to read this probably in a week or even less, and master most of the knowledge there. By saying master, it means the AI can complete 90% or even more of the sentences in the training data without any error. So you can imagine that it's kind of a new, much larger Wikipedia, and it tells you all this domain science, all these real questions. It can answer these things for you with errors. And what we can do, human is actually good at judging the correctness of the question or of the answer. Then you can do your own research and you can verify whether it's correct or not. So to me, it's more like, my background is more in computer science by PhD training. So to me, it's more like another P and NP questions. In P questions, we can find efficient polynomial solution to fix this. And in NP problems, we can verify the answer using the polynomial time algorithm, but we cannot find an efficient enough algorithm to find a solution. But ChatGPT gives me some hope that it can propose some solution. Well, it can be wrong, but we can, as a human, we can quickly verify whether this is right or wrong. And we can criticize which part is wrong to ChatGPT, and it can give you a new proposal. And if you do this back and forth for a few rounds, you will be able to find some reasonably good solution. At least it helps me to find some piece of code that I want to write from the web too. And I try to use a Google, to use a Microsoft Bing to search for it. Doesn't work very well. And then I turn to ChatGPT. Only 3 rounds of conversation, it generates the answer that I'm looking for. And I can verify the correctness myself. So it's more like reducing the problem of finding a solution to just judge the correctness of the solution. So that's kind of the hope I see. And I think that can be a very strong use case in many different applications. To give a summary to what we covered today, ChatGPT is basically a GPT model that can chat. And the GPT is a large language model trained by reading the documents from the left to right to understand what's going on there. And I also put together a recommended reading list. I know it's long, but that's really the history, a short history of these large language models. So in the first one is attention all you need about transformer. And then you can see the Elmo, the bird, the Bart, the hugging face, all these things. And the language model are few shot learners. That's the first time people think about the in-context learning. And then we have this instruction following things. And there's another more comprehensive survey about pre-training, prompt, and prediction, this new paradigm and emergent ability I mentioned, and also the spark of the AGI. This work provided by Microsoft research people who have the best access to GPT-4 model. And I think they did a lot of things to do the benchmarking to understand what's going on with this extremely large language model. And there's another one about the benchmarking for ChatGPT. The conclusion is it's a jack of all trades, but master of none. So it can do a lot of things, but not the depth is not good enough compared with a well-trained domain scientist. And instruction tuning with GPT-4, there's very new work by the Microsoft people again. They try to use the GPT-4 to tune smaller large language models, and it can be something more automatic, like a recursive call to these large language models. So at the end, it's 2 blog posts by OpenAI about their products. So that's pretty much all I'd like to share today. Thank you.